In the previous video, the introduction to calculus, I told you guys about limits, and I think I made mention that limit is the analysis of a function as a function at a particular point. Let's say that. I showed you with the function 1 over x. So I was saying that as x approaches this point A, then the corresponding y value would be the limit of your function.
Took a swing at a wrecking ball and I prayed for my downfall.
Now, when you have, say this function is equal to x squared minus 9 over x minus 3. That is your function. And you're supposed to find the limit of this function as x approaches the point 3. Let me fix this arrow. So as x approaches the point 3. That's your question. Now, how you go about this in limits, especially when you're doing simpler questions, some questions you can directly substitute values into the question. Right away, we see that if we substitute 3, we'll get 0 over 0, right? Because 3 squared is 9, and 9 minus 9 would be 0. And if I substitute 3 here for x, then I'd have 3 minus 3, which is 0. And that is direct substitution with limits. Some questions can be worked like that, but in this case, we can see that we get 0 over 0. In limits, we see that this is indeterminate. If you're, that's a E right there. If your teacher wants you to write it out, then you can. I choose to write an I. So this is indeterminate. A next term you should know when doing or dealing with limits is undefined. Undefined is if you get something like that when you evaluate. This is undefined because you can't divide a number by 0, right? So this is undefined. This board is so small, I don't have any space. And by the way, I was planning on using VideoScribe to do videos. If you would like me to do that, then please leave that in the comment section. But for now, I will just stick to this small whiteboard with so much limited space. But that's that. We see that we can't directly substitute. Now we can do some manipulation to this, so we can then go and substitute. In limits, you can factorize, and you use your algebra techniques. That's why I told you guys that calculus is just an extension of math, so you will continue using your math skill. So from algebra, you can factorize. I know I've not done any algebra videos, but you must know algebra if you are doing calculus. So from algebra, you would know how to factorize, right? And rationalize as well. So you can manipulate your function by rationalizing, factorizing, and all different types of methods from previous knowledge. And in calculus, you will learn a new technique or a new method called L'Hopital's rule. But I won't show you L'Hopital rule until I've gone through differentiation, because you need to differentiate in order to use L'Hopital rule, and you must have in one indeterminate form. So this is an indeterminate form. A next indeterminate form is infinity over infinity. And sometimes it's better if I write instead of say. So this is also indeterminate. And these are 3 indeterminate forms where when you evaluate, if you get these values, then you know that you can use L'Hopital rule. But when I'm at the L'Hopital rule video, I will go more in depth. So that's just for that. Back to this question. As I was saying, when you're working with limits, sometimes you need to manipulate. So in this case, we will factorize. I can write this as this: x squared minus 3 squared over x minus 3. And again, I can rewrite the numerator as x minus 3 x plus 3 over x minus 3. And I can cancel these. So I'm left with x plus 3. And now if I substitute my 3 for x, I'd have 6. Directly substituting, for some cases, you can directly substitute and then you get your limit. For some cases, you have to do some manipulation. As you saw just now, I have done that. I've factorized my numerator. Sometimes it's not the numerator that you factorize or rationalize, it's the denominator. You can also use a table to do the same thing and get the same answer. So remember, I got 6 for my limits. Let's use a table. I'll rewrite the function right here. So the function was x squared minus 9 over x minus 3. Remember that my limit was 6. Now, let's draw up a table and show you guys how you can use a table to do this and get the limit. It takes more time, but it works. So this is how you do. You create a row for x values and a row for values you will get from your function when you plug in those x values. From the intro to calculus, and I think I mentioned it in this video as well, when you see this notation, you're not at 3, you're approaching 3. So you're never at the value of 3. So I will substitute values into this function that is closer and closer to 3, but never at 3. So let's do that. If I have 2.9, it's a value that's close to 3. I'm getting closer and closer to 3. By the way, let me put 3 in the center to show you guys. So I'm approaching from the left and from the right. So this is 2.9, not 29. Now if I substitute these values, these are the values that I would get. So if I substitute 2.9 in this function, you can do that in your calculators. If I substitute this in this function, I would get 5.9. If I substitute this, I would get 5.91. If I substitute this, I get 5.991. If I substituted this value for x, I'd have 6.0001. This is a 0. If I substituted this one, I'd have 6.001. If I substituted this one, I'd have 6.1. Now, remember that the limit is the value that these values are approaching, the values in red. So your x values are these. You're approaching 3. You're not at 3, but approaching 3. So the value here is approaching the limit as well. So you can see that 5.991 and 6.0001 is approaching the value 6, just as before, because 5.991 is pretty close to 6 and 6.00001 is pretty close to 6. And if I had substituted a value that is closer to 3 than 2.991, I'd get a value for my function here that is closer to my limit, 6. For the next example, I'm supposed to find the limit of x squared minus 3x over x squared minus 9 as x approaches 3. So if I directly substitute 3, again I will have 0 over 0. So let's factorize. So in my numerator I could have x here and I'd have an x here minus 3. Right? And I'd have that over x squared minus 9, which I can rewrite as x plus 3 times x minus 3. Now I can cancel these, right? So I'm left now with x over x plus 3. And if I substitute my value of 3, I'd have 3 over 3 plus 3, which is 3 over 6, which is the same thing as an half. Right? 3 into 3, 1, and 3 into 6, 2. So my limit would be a half. Now if I'm supposed to use the table to do the same question, I'm supposed to get an half, right? So let's do that. So remember that the limit was an half. So let's go. So here's my table, and remember I'm approaching 3 again. So in the last video I used values like 2.9, 2.999 and so forth, but just to show you that you don't have to use my values, you can use any values as long as the values are approaching 3. So I went ahead and I put these in a calculator, and this is what I got. Remember, I got the half for my limit. Now we can see that 0.492 and 0.58 both are approaching this value, right? And if I add numbers closer to 3, if I add 3.000 going on 1 and 2.99999 continuing 1, I have my values pretty much closer to 0.5 than they are. So I can see that as x approaches 3, because 3 is here, x is approaching 3 both from the left and from the right. The values are approaching 3. And as they approach 3, my function approach 0.5. The same thing as an half. So we can see that manipulating your function and plugging in values in a tabular form, then you will end up with the same answer. Thank you guys for watching.
Took a swing at a wrecking ball and I prayed.